Hey everyone, and welcome to This Explainer. Today, we are diving into what is honestly the most profound shift in software engineering we've seen since high-level programming languages were invented. We are officially moving away from an era defined by syntax, meticulously typing out every single curly brace and semicolon, and we're entering an era defined entirely by intent. You're no longer just translating requirements into a language a machine understands. Instead, you're expressing what you want to build and trusting intelligent systems to do the heavy lifting of translating that intent into working software. It's a total game changer. Here's a quick look at our agenda for today. We'll be covering the vibe coding phenomenon, the shift from syntax to intent, the engineering spectrum, the new AI-driven SDLC, the model versus the harness, and finally, conductors and orchestrators. All right, let's jump right in. Section 1. The vibe coding phenomenon, a new development era. To really grasp where development is heading, we've got to look at the reality on the ground right now. Just check out this number, 41%. As of early 2026, a staggering 41% of all new code is AI-generated. And get this, 85% of professional developers are using AI coding tools on a regular basis. So yeah, this isn't some distant sci-fi fantasy. This is literally how software is being built today. Now, the actual term vibe coding comes from a viral moment back in early 2025. Andrej Karpathy dropped this exact advice online, telling developers to, quote, fully give in to the vibes. It basically validated this whole new workflow. You just prompt an AI in plain English, eyeball the output, and if it seems to work, you just roll with it. Hit an error? No problem. Just copy and paste that error message right back into the prompt. It's fluid, it's fast, and honestly, it feels entirely different from the traditional grind of coding. So what exactly is vibe coding? At its core, it's an AI-assisted workflow, relying heavily on natural language with, well, pretty minimal verification. But hey, let's be super clear here. While vibe coding is absolutely fantastic for throwing together a quick weekend prototype or a one-off script, it has some pretty severe limitations. I mean, if you march into your CTO's office and announce you're going to just vibe code the company's new core payment processing system, yeah, alarm bells are going to ring, as they should. To build robust, reliable systems, we have to move way beyond just disposable code. Which brings us to Section 2, from syntax to intent, the evolving interface. Just take a second to think about the wild journey we've been on lately. Remember 2021? We were absolutely blown away by simple autocomplete, just the editor guessing your next few characters based on token production. Fast forward to 2023, and we shifted to chat-based generation, where the conversation itself became the interface. But now, looking at 2025 and 2026, we have firmly landed in the era of autonomous agents. We're talking about AI systems that can clone entire repositories, plan massive architecture changes across multiple files, run tests in secure sandboxes, and literally submit pull requests on their own, all without a human typing a single line of traditional code. Wild, right? Section 3, the engineering spectrum, bridging the gap. Now, we really shouldn't think of AI usage as a simple binary, like you're either using it or you're not. It's much more of a spectrum. On one far end, you have the casual Wild West of vibe coding, but on the other end, you have what we call agentic engineering. The real differentiator here isn't whether you use AI, it's how strictly you verify what the AI spits out. In agentic engineering, your intent isn't just a casual chat, it's provided through formal specs and memory files. And crucially, verification happens through rigorous, automated test suites and language model judges. The risk profile totally shifts from high to low because human judgment is systematically locked in at every critical checkpoint. Making that shift to agentic engineering actually requires a whole new skill, which we call context engineering. Since these models need the same deep context a human developer would, you have to make a huge architectural decision, static versus dynamic context. Think of static context as your global memory and core instructions. It's always loaded, meaning the token cost hits you hard on every single turn. Dynamic context, on the other hand, like specific agent skills or retrieved documents, is loaded only when needed. That makes it super efficient. Deciding what information goes where, that's basically the new core engineering task. Section 4, the new AI-driven SDLC, a transformed lifecycle. There's this incredibly fascinating compression of time happening right now in software development. In the traditional iterative model, implementing code takes weeks. But in the AI-driven model, that implementation phase shrinks down to literally minutes or hours. Because of that insane speed up, your requirements, your architecture, and your verification, they don't go away. Instead, they become the new human-paced bottlenecks. When an AI can whip up a feature in 10 minutes,
The quality of your initial spec and the rigor of your testing become, without a doubt, the most important parts of your entire day.
To really thrive in this shift, you have to adopt a completely new mental model. We call it the factory model. In this new world, your primary output isn't actually the code itself anymore. You aren't just an assembly line worker typing out boilerplate syntax. Instead, you're the factory manager. You design the system, the specs, the tests, the feedback loops, the guardrails that produces the software. You hand the agents their success criteria, and you let them iterate until they hit your bar for quality.
Section 5. The model versus the harness, the engine and the car.
You know, when people first start building with AI, it is so common to treat the model like it's the whole entire system. If an agent fails, we point fingers at the model. If it succeeds, the model gets all the glory. But honestly, that's a massive misconception. Try thinking of the AI model as just a raw, naked engine sitting on a wooden pallet in the middle of a factory floor. An engine can't drive you to the grocery store on its own, right? The harness is what matters. The harness is the car, the steering wheel, the road, and the traffic laws, all combined into one.
So it really all boils down to this simple equation. Agent equals model plus harness. Without a harness, a raw model can't actually finish anything. It's just a text predictor. The harness is that absolutely crucial scaffolding. It gives the model tools to act, memory to recall things, safe sandboxes to execute code in, and hard enforceable constraints to keep it from going off the rails.
Let's unpack what actually makes up this harness, because the surface area is honestly massive. It's the instructions and rule files giving the agent its identity. It's the tools and APIs it can call on the fly. It's the secure sandboxes for running code safely. And it's the orchestration logic routing everything, plus the guardrails that block bad actions and the observability that traces every single token. So, here's a pro tip. When an agent fails to build what you asked for, don't just reflexively blame the model. Almost always, that failure traces back to a missing tool, a vague rule, or a bad configuration somewhere inside this harness.
Finally, Section 6, Conductors and Orchestrators, the new developer role. As the harness does more and more of the heavy lifting, your daily role as a developer transforms. You're going to find yourself fluidly shifting between two very distinct modes of working. The first mode is the conductor. This is your real-time, synchronous, right there in your IDE work. You're actively directing the AI, watching the code generate before your eyes, and course-correcting on the spot. The second mode is the orchestrator. This one is strictly asynchronous and high-level. Here, you're defining broad goals, assigning them to background agents, getting up to grab a coffee, and reviewing the pull request later. Operating effectively in that orchestrator mode, that demands an entirely new set of skills. You're not just banging out syntax anymore. You're mastering specification, task decomposition, and big-picture system design. You're evaluating the outcomes of your agents rather than tracking your own keystrokes. Essentially, you're stepping up to manage a team of tireless digital developers. But as we embrace all these incredibly powerful new ways of working, we hit this persistent and honestly fascinating roadblock in AI development. What about the 80% problem? Here's the reality of the 80% problem. AI agents can rapidly, almost miraculously, generate about 80% of the code you need for a feature. But that final 20%, the ambiguous business requirements, these super subtle edge cases, the complex architectural trade-offs, yeah, that still demands deep human context and judgment. The AI errors we see today aren't just silly syntax typos. They're deep conceptual misunderstandings that can look perfectly correct at first glance. Because of this, your human expertise is literally more critical than ever. You don't get faster by blindly accepting everything the AI spits out. You get faster by letting it handle the easy 80%, so you can focus your brilliant human judgment precisely where it matters the most. We've covered a massive paradigm shift in this explainer today. We've journeyed from the wild west of vibe coding all the way to the strict, factory-like discipline of agentic engineering. We've seen how the development lifecycle is compressing, how context and harnesses actually matter way more than raw models, and how your daily role is elevating to new heights. So in this new era, where intent is the true interface between you and the machine, you have a pretty critical choice to make about your future. Will you hold on tight to your syntax, or will you become the orchestrator? Something to think about the next time you sit down to build.